In this video, we're going to take a look at some types of factoring that we need to review. So I'm just going to use some examples to review all the types of factoring we need up to now. So my first example will be 20p squared minus 15p. So we have two terms. They are not perfect squares, so the only thing we could do is factor out a greatest common factor. So between 20 and 15, we could take out 5, and then each term has a p that we could factor out. So if I take out 5p, I would have 4p minus 3 left over. And then that would be all that I could do for that one. Let's look at another example. What if I have x squared minus 9x plus 14? This one has three terms, so it's a trinomial, and my first value of a right there is equal to 1. It's an understood 1. So I just need to figure out what would multiply to give me 14 and add up to negative 9. So 14 and negative 9, I could use negative 2 and negative 7. They'll multiply to give me 14, and they will add together to equal negative 9. So then I simply write x minus 2x minus 7. And then that's it for that kind. So that is a trinomial where a equals 1. In other words, that first coefficient is just a 1. Then how about this example? So for w to the fourth minus w squared, it would first have a greatest common factor. We could factor out w squared, and we would have w squared minus 1 left over. But you always want to factor as much as you can, and what's left over is considered a difference of squares. So we would factor that into a sum and difference of the square root of each term. So we would put w plus 1, w minus 1. So in the first step, we used greatest common factor. And in the second step, we use difference of two squares. So I'm going to abbreviate that with the word dots. Let's look at another example. What if I have, let's say, 2x squared minus 13x plus 20? So for this example, I do not have a greatest common factor because I can't take 2 out of 13. So this is what we call a trinomial where a is not equal to 1. So we have to use a little different method than we did for the regular trinomial where a was just equal to 1. So we start with 2 times 20. That's our a times our c value. So we would have to multiply to get 2 times 20, which is 40, and we need to add to still get the negative 13 that's in the middle. So 40 and negative 13. Negative 8 times negative 5 would give us 40, and negative 8 plus negative 5 would add up to negative 13. But again, it's different than the trinomial we looked at here because of the 2 that's out front. So let's write our first term, 2x squared. We're going to write negative 8x or minus 8x minus 5x, and then bring down our last term of 20. And then we've turned it into a grouping problem. So we're going to group our first two terms and take out a greatest common factor of 2x. And then we have x minus 4 left over. Then we're going to take out the greatest common factor of the next two terms, which would be negative 5. If the third term is negative, you want to take out the negative. And then we would have x minus 4 left over. And then our factors would be what we took out, which is 2x minus 5. And then what they had in common would be our other factor. So this one, we used grouping in order to factor a trinomial where a was not equal to 1. So let's look at one more example of grouping. So what if I'm given 3t cubed minus 7t squared minus 3t plus 7? This would be a grouping problem because it has 4 terms. So it works differently than ones that have less than 4 terms. So we would group the first two and group the last two and take out a greatest common factor from each one. So in the first two terms, I could take out t squared, and I would have 3t minus 7 left over. And then from the next group, I could take out just a negative 1, but that will help my factor that's left over to match the 3t minus 7 from the first group. And then I need to put together the t squared minus 1 that I took out, and the 3t minus 7 is my other factor. But notice I have t squared minus 1 right here, which is a difference of two squares. So we would need to factor a little further and put t plus 1, t minus 1 for that first factor. So sometimes you have to use different types of factoring within the same problem to get it to be factored completely. But hopefully this is a quick review of multiple types of factoring.